before we get too far, I want you guys to actually make sure that we're all at the same point with our calculator. So first thing you're going to do is just turn it on. You're going to turn on the calculator, and we're going to go into the mode. Now, when your calculator is cleared, everything should be to the left. So if I were to actually, and you don't need to do this, but if I were to actually clear my calculator right now, so at the end of the year, this year probably not so much, but at the end of the year, we usually clear your calculator. And when your calculator is cleared, it puts everything into default mode. And for you guys being in grade 10, when we get into the trig unit, there is one important thing you need to know, and that's when we clear your calculator, it goes to the default mode, which means it goes to radian mode. And when we are working with trigonometry, everything you do has to be in degree mode. So the reason I'm resetting my calculator is just so you can see what it looks like afterwards. But depending on how much you've played with your calculator, you guys are all going to have different settings. So we're going to get everybody set up at the same point here. Apparently mine's taking a really long time to reset today. So since it's frozen, I'll just close it out and reopen it here. But normally it'll reset pretty quick. So I got my calculator, got it turned on. If you guys go into your mode button, so that's right next to your second degree or second function button, click mode. Normally we want everything to the left, but because you guys are doing trig, I would get in the habit of keeping this in degree mode. When you get into grade 12, you will use both radian mode and degree mode, and we'll explain what those are down the road. But for your purposes for grade 10, and when you take math 20, everything is done in degrees. So make sure under mode, everything's to the left except for degree. Now, we are going to be doing we're going to be graphing. Now, some of you might have equations in your calculator right now. If that's the case, just clear them. If you have anything highlighted up here, for example, you might see your plot 1 is highlighted or your plot 2 is highlighted. All you have to do is click on the highlighting and it'll turn it off. So when we're graphing, we don't want any of our plots turned on. If you take 20-2 or 30-2, you'll get into doing that more, where you do calculator regressions and so on. You don't need to worry about that right now. How did I get? Oh, sorry. Good question. So you click on your y equals button. So click on the y equals button up here. And if you have anything cleared or anything in there, you're just going to clear it. And then again, these plot 1, 2s, and 3s, you don't want any of those on. Now, there is so much I could get into with the calculator. And again, thank you for asking that. If I go too fast, please make sure I know. And I will try to answer you as soon as I can. All right. So making sure that that's all cleared out. Now, when you're in with your y equals there and you need to get out of it, you just quit. So you're going to push the second function mode button. So second function quit, and that takes you back to your main screen. So to turn the plot off, if I'm up here and this is highlighted, I just go up there and hit enter and it turns it off. So the way we turn things off and on is we just highlight them and then hit the enter button. So it's the same thing. I'm going to go back to my mode. So if I click on mode, here, if I wanted to, for example, go from radians to degrees, if I highlight radian and hit enter, it's now in radian mode. If I want degree mode, I hit enter and it puts it in degree mode. What these are telling me up here, the top is telling me normal mode, scientific, and I believe that's engineering mode. So scientific would mean everything is written in scientific notation. You probably don't want that. The float, I keep mine on float. If you use 0, 1, 2, 3, 4, then it's dictating how many decimals show up on your screen. We're using function mode. There is polar and sequential and so on. Again, most of these you don't need to really worry about. We're just going to keep everything standard. So you're going to quit out of there. Now, some things you might want to be aware of. If ever you're looking for a specific function and you can't find it, you push second function 0. So second function 0, and that's your catalog. And that has every single thing, every function that this calculator can do is in there. And for example, when we get into 30-2, you're going to have to do something with your diagnostics. It's alphabetized. I can literally, it's in alpha mode right now. I could choose D, which is right above the X to -1, and it'll drop me to the Ds. So I can navigate through there just using my alpha code. 99% of the time, you're never going to use that. But if you're ever stuck finding something, you can use your catalog to find it. So let's get into some basics here. So if I want to graph on my calculator, right now I want you guys to set your zoom settings so they're the same as mine. So I want you to go to zoom. So that's the third button on the top here. Click on zoom. And when you're in your menu boxes, you don't have to arrow down. You can just hit the number. I'm going to arrow down just so you can see it moving. But zoom standard is the default that you want to use. So zoom standard, you could just type 6 or hit enter. Zoom standard is what your graph should look like. So right now you guys should all have a clear graph, a clear grid, and nothing in your y equals. A zoom standard is a grid that goes from -10 to +10 and -10 to +10. If you click on your window button, which is right next to y equals, this tells us what our window settings are. And so it tells us that our grid went from -10 on the x-axis to +10 on the x-axis. And the scale is what we're going up by. So that means that we're going from -10 to 10, and there's a tick for every one that we jump. And then the y goes from -10 to 10, and it's one tick for every jump we go. If, for example, I wanted to go, and you don't need to do this right now, but if I wanted to go from -100 to 100, and then -100 to 100, it would make sense to change my scale. If I don't, this is what it will look like. A big black line. Again, you don't need to do this on your calculator. I'm just showing you what happens. So if I'm going from -10 or -100 to 100, it would make more sense to go up by tens. The reason I get that big black line is because my calculator is literally trying to put one line for every number between -100 and 100. And so if I change my scale and go up by tens, now my grid looks the same as what I had before. It's just that now I'm going up by bigger numbers. So when in doubt, zoom, and then 6 for standard. So zoom and then 6 for standard. And then if I look at my window settings, I'm going from -10 to 10, up by ones, -10 to 10, up by ones. All right. So you guys have spent this unit learning how to graph learning how to graph on paper. Now we're going to graph on your calculator. One of the reasons that it's super important that you are able to rearrange your equations and solve them for y is because when you want to graph on your calculator graphs y equals. And so it has to be written in the form y equals. So for example, if I wanted to look at 2a, actually I'm going to go even easier. 2b is y equals x minus 5. Well, if I want to graph x minus 5, I use a variable button. So you don't go alpha x. It will work in some cases, but I have seen the odd calculator where using alpha x actually causes them trouble. So if you want to type in x minus 5, right next to the alpha button, there's this button here that's got an x, a t, theta, and an n. That's your variable button. And so you're going to click on your variable button, x minus 5. So no matter what your variable is, if it's a p or a q or an r, we're still going to use x. So if I want to graph y equals x minus 5, that's what I'm graphing. We know that the slope is 1 and we know that the y-intercept is -5. We just want to see what it looks like on our calculator. So when you hit the graph button, it should look like that. All right. Now, we can do some neat things on here. For example, let's say that you're checking your answer and you want to see if you graphed it correctly. So the slope we can't figure out just by looking at the calculator. We'd have to find specific points and then calculate it. But the y-intercept we can. Who can tell me what's special about a y-intercept? Maybe a better question. If I know mine didn't turn out like that. Okay, so Ryland, look at your y equals first. Does yours say, oh, and good, I'm not sure if this happened to you. Lots of times people will go x minus 5, and they put the negative symbol. If you write this, if you go x negative 5, that will give you a very different graph. That's what you should have. This is what you'll get if you did x negative 5. Because what your calculator is doing is it's going negative 5 times x. So it's really important they use the subtraction sign and not the multiplication sign. So you should have x minus 5. Is that what you did? Okay. That's a common mistake, so I'm glad you asked. So x minus 5, and then we're going to graph. So maybe a better question for me to ask, if we have a y-intercept, what does x equal? Anyone call it out?
Zero.
So if we have a y-intercept, x equals 0. Well, on our calculator, we've got this trace button right here. Now, if some of you have Mr. Hillier next year for 20-2, he may tell you to use value. It's exactly the same thing, so I'll show you both. But if you just push the trace button, you can actually trace up and down the graph. And I call this my bug. So it's the bug moving up and down the graph. If I had two graphs on here, again, don't do this, I'm just showing you how it would work. If I had two graphs on here and I wanted to trace, if I move left and right up the graph, left and right moves the bug up and down the cursor, or up and down the function. If I want to switch functions, I push up or down. So up or down, and if you notice as I'm switching graphs, the equation is changing in the top left corner. So it tells me which function I'm on. All right, I'm just going to turn off that other one. Now, if you want to turn off an equation, you don't have to clear it. If you're using an equation and you think you're going to need it later, you can keep it in there. Just hit enter, and that equal sign turns off. Okay, so now I'm just going to have the one graph on there to work with. All right, so you can trace up and down. You can trace up and down on the graph. We also, once we've graphed this, have a table of values. So for some of you, making a table of values was a bit of a challenge. If you push second function graph, so second function and then graph, this will take you to a table of values. And that's telling you all of the points on the graph. Now, if some of you have yours going up by a decimal, it just means that you're at a different setting, but likely yours all looks like this. Okay, and I can go up and down, and these are all of the coordinates that fall on that graph. Now, if you wanted to change your settings, I would not do this right now, but if you wanted to change your settings, you can do that. For example, let's say you want to go up by 0.1s. Don't do this on your side there, but I could go second function window, so second function table set, and I can adjust my table settings. So right now I can say what I want my table to start at, and I can say what I want my table to go up by. So let's say I want to go up by 0.1s. I can do that. And now when I when I go to my table's now going up by smaller amounts. So you could adjust your table, but in all honesty, the amount of time we use our table, I don't think it's really worth it to change it. So I probably wouldn't bother with that. Now, tracing up and down your graph is useful, but not really useful if you want a specific point. So this is where the trace button is even cooler. If you push the trace button, remember, you guys, a couple of you said that when we know a y-intercept, x is 0. If you type trace and just type 0 and hit enter, it tells you 0, -5. Now, I know when we hit trace, it already started there. That's just because it typically defaults to that. But let's say I want to know what is the value of y when x is 2. Well, I trace at 2, y is -3. If I trace at 8, y is 3. If I trace at -2, y is -7. Here's something you have to be aware of, though. If I want to trace at 11, I'm going to get an error message because we can only trace values or look for values that are in our window settings. So if you need to trace beyond that, or you need to look at a point beyond that, then you have to adjust your window settings. So if you get an error like this, I just click 2 for go to, and it takes me back. Y values do not have to be on screen, but X values do. So I want you guys to graph this one here. So we're going to go in and we're going to clear our graph. And I want you guys to graph the y equals negative 1/2 x plus 3. And I'll do it on screen at the same time. Notice this time I did use the negative symbol, so negative 1 divided by 2x plus 3. Because our calculator is scientific, I don't have to put the negative 1/2 in brackets. It doesn't hurt if you do, but you don't have to. And if I were to graph that same graph down here, you don't need to do this. I'm just showing you how they're going to give me the same answer. Negative 1/2 x plus 3. If I graph those, I'm going to get the same graph both times. Okay, so you won't see a separate line because they're not any different. I'm just going to go back and clear that out. What I want you guys to do, and I'm gonna delay mine each time. I'm gonna tell you guys to trace at a point and find what it is, and then I'll type mine in about half a second after you. So I want you guys to trace at 0 to find out what the y-intercept is. And then trace at 2. You don't have to retype trace. You can just hit the number. If you're in trace mode, you can just keep hitting numbers. Trace at negative 5. And then find out what the value of y is when x equals 2. All right. So that's how we're going to find those values. Now I did mention 20-2. There are some teachers who say value instead of trace. I do know Mr. Hillier's one of those teachers because and I did value up until I learned about trace as well. So if ever you have a teacher that says value, this is how you would do this. So value is going second calc. So second function trace. Second function trace. It takes you into this value window. You're going to use this a lot in Math 20. Doesn't matter whether it's -1 or -2. You're going to use this a lot. Value is the first one. And value does the exact same thing as trace. So you type in what you're looking for, and it'll give it to you. If you want a new value, you got to go back in and type value. So I use trace just because it's a little bit quicker. I can look for lots of different values at a real quick pace. But again, you could go second calc, click 1 for value, type in the value you're looking for, and it'll give you the amount. Okay. Other things you can do in that second calc. So if I go second calc or second trace, other things you can do in there, when we get into parabolas next year, you can look at your max and your min. We can find out where two lines intersect, which we're going to be doing later on this year. So I'm not going to get into that right now. If you're into calculus, you can actually do derivatives and integrals and all of that stuff. We're not going to deal with that right now. So we're just going to quit out of there. Now, there are some other things that we can do. For example, if I've got 3x plus y equals 7, in order to put in that in my calculator, I have to write it in y equals form. So you would know to subtract 3x from both sides and go negative 3x plus or negative 3x plus 7. That's how we'd write it on paper. But you don't have to put it in the proper format in your calculator to still get the right answer. So sometimes I'll use my calculator to check my work. For example, if I want y by itself, I just have to subtract 3x. So on my calculator, I'm just going to write 7 minus 3x. It's not written in y equals mx plus b form, but it's still going to give me the right answer because I haven't done anything mathematically incorrect. So if I were to rewrite this, I would write it as y equals negative 3x plus 7. This is the same thing. And if I graph it, it's going to look like this. Okay. Just need a minute here. I'm just going to switch files. All right. All right. So I'm going to try to have the calculator on screen and then this part on screen as well so that I can, I'm going to write for a couple of these things as well. So if I wanted to rewrite this one here, it would be y equals negative 3x plus 7, which means that my slope is negative 3 and my y-intercept is 7. Well, if I trace here at 0, I'm going to get that. Now, if I have this other one here, negative 4x plus 2y equals 10. Well, if I wanted to do that mathematically, I have to first have the 2y equals 4x plus 10. I had to divide by 2 on both sides. And y equals 2x plus 5. So if you're asked to write it correctly, then that's what we need to do is y equals 2x plus 5 using slope-intercept form. But sometimes if we make a mistake in the algebra and then we put in our calculator with that same mistake, we're not going to catch our mistakes. So here's a way to work around it. You could write in y equals 2x plus 5. But then we can also just do the math and let our calculator work for us. We know that the first step is to add 4x. This will have to be done in brackets. So 10 plus 4x. So I'm not simplifying anything. I'm just telling the calculator what to do. 10 plus 4x divided by 2. And if I hit graph, I should get the same. Here, guys, there we go. I should get the same graph on both spots, and I do. So my equations look the same, so I know that mathematically B is written correctly. Okay. I want you guys to try. C. So try 1C here. Try putting that one in your calculator. Try putting it in the way that you would expect to put it in. So rearrange the equation and then try putting it in the other way and see if you get the same answer. If you need to follow along while I'm doing it, that's totally fine. So when you rearrange that one, it's not a very nice one to play with. We've got negative 3 over 2x minus 9 over 2. But if I wanted to just shortcut it, I know that my first step is to take negative 9 and subtract 3x. So I'm just going to write 9 minus 3x in brackets. And then I know I'm going to have to divide by a 2 because in order to get y by itself, I have to divide by 2. Sometimes that's quicker to put in our calculator than to put in this other format. And if we've made a mistake, I have a way to check that answer. Okay, so obviously I made a mistake. So this is where I go back and check my math. Okay, so I had negative 3x minus 9. And I divided it by 2. So I've got a negative 3 over 2x minus a 9 over 2. So I'm still pretty sure my math is good there. And can anybody see where I made my mistake? The mistake happened in number 2, just in how I entered it into the calculator. Exactly. Thanks, Kaylee. So yeah, so I actually did not do that mistake on purpose, but it does happen. So inside there, I should have had a negative. Now, This is probably actually good that I made that mistake, because when I want to insert a number, I can go second function insert and type my negative. I don't have to retype everything. So if you've made a mistake, you can just push second function insert and put it in there. If I put it in by mistake, I can go back and just hit the delete button. But second function insert and type that there. Now when I graph them, they should be correct. So again, that's a way for me to check my work and make sure that I've done it correctly. If you're not getting the same equation using both methods, then something went wrong. And so it might be a way to just check your work. All right, some other things that you can do. When you have a graph on here, you can zoom. And so zoom standard is just the typical 6 by 6, 10 by 10 grid. But we have other zooming features that we have as well. For example, we can zoom in. So number 2 is zoom in. And so nothing happened right now, but you should see a little cursor flashing right in the middle. If I hit enter, it's going to zoom my graph in. But it's zooming in from the origin. I'm going to go back to the normal one. So zoom, I'll go zoom back to the normal one. So zoom standard. I can also zoom out. So I can zoom and I can go to zoom out. And if I hit enter, it's going to zoom out. Now, if you want to know how much it zoomed out, you can always click on your window settings. Window will tell you how much it zoomed out by. So now it's going from -40 to 40 and -40 to 40. Okay. I don't use those very often. There is one that you will see people use a lot down here, especially when you get next year into 20-1 and 20-2. You're going to be working with parabolas and some other crazy formulas and crazy graphs. So some people will use zoom fit because sometimes it helps you find your graph. So zoom fit, we'd hit enter. So 0 is zoom fit. In this case, it didn't change much. Okay. But if I had some bigger graphs, like let's say, don't change yours. I'm just going to turn these off for a minute. Like let's say next year I have -x squared minus 40x plus 100. Well, the window settings are going to have to change for that. So if I push zoom fit, 0 for zoom fit, it will actually help me find my graph. So it will adjust my window settings for me to fit the main components of the graph on screen. All right. I'm going to just go back and change that because you guys don't need to worry about that for today. And I'm going to zoom standard because I want to have it look like normal again. Something else that comes in handy, and I find myself using this a lot more, is zoom box. So when we got zoom, there's zoom box. If I hit enter, you'll see a little cursor flashing there again, but I arrow it to where I want it. I hit enter, and then I arrow down. I want to highlight my X and Y intercepts. So it's just almost like an etch-a-sketch. It's very painful and slow. But you make your box, and when you hit enter, it's going to zoom in on that part of your box. So if you were looking for a specific point, you could zoom in. Now, something that we don't teach really in grade 10, but I'm going to show you how to do it because some of you have probably already figured it out. We know that if I draw a line on the x-axis, it will be a horizontal line. And if I draw a line on the x-axis, I can actually intersect it with this point here. So before we said that when something crosses the y-axis, that's the y-intercept. When something crosses the x-axis, that's our x-intercept, and y equals 0. And so if I were to draw a line at y equals 0, it will intersect with this line here, and that's how I'm going to find out what my x-intercept is. So you guys have learned how to do it algebraically by plugging in 0 for y and solving for x, but you can do it graphically as well. So I'm going to go y equals here, and I'm going to draw a line at y equals 0. So you can probably do this along with me. You've got -3/2x minus 9/2 should still be in there. And y equals 0. Just because our window settings might all be different just make sure yours is in zoom standard. So I'm going to type zoom and then 6 for standard. Now, it looks like there's only one graph there, but that's just because our y equals 0 is running right along that y-axis, so we can't see anything. If I wanted to trace, I type 0, negative 4.5. If I arrow up, that's when you'll see that equation is actually there. Remember, if you arrow up or down, that moves you from one equation to the next. So I can see that there is an equation there. I just can't see it because it's right on top of the axis. If you want to find where your x-intercept is, the only way to find an x-intercept is to find the intersection between these two. Now, I guess I'm not totally right on that. There is another way to do it. We just don't talk about it in grade 10. But if I want to find my x-intercept, I'm going to draw a line at y equals 0. And then you're going to push second function trace or second function calc. And this is where we find all the different functions we can do with our graph. We want to find where the two lines intersect. So this is number 5 for intersect. And you're going to hit enter. And really the easiest thing to remember is just enter, enter, enter. But I'll explain why we're doing that. So first curve, it's telling us you're on this equation. Do you want to intersect this line with something? And you say yes. So that's the first enter. Notice it's shifted now to the other equation. And they say, is this the other equation or other line you want to intersect with? And you say yes. So that's your second enter. If you had more than 2 lines on there, then you have to adjust between your lines. But by default, you're only ever going to have the ones on there you need. And then they say, do you want us to figure it out? They're not really guessing. The calculator is actually getting the answer. But do you want us to get the answer? You say yes. And it tells you your intersection is negative 3, 0. So the x-intercept for that graph is negative 3, 0. So knowing that, you can actually check your answers when you do your work. Okay, again, I purposely did this after you wrote your test, but you can use it going forward. So if I wanted to show you the quick way to do that, second, calc, 5 for intersect, and literally enter, 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 and you get your answer. If you were doing something like this, you don't need to graph this right now, but if I wanted to intersect something like this where I have 2 intersection points, then I'm going to go second calc. I'm still going to do intersection, and I'm going to intersect with this one. I'm going to intersect with this one, and I'm just going to make sure that my cursor is close to where I want to intersect it, and I can find an intersection point. If I want to intersect with the other one, notice again, I've got 3 graphs graphed right now, so I got to be careful which equation I'm graphing on. I'm going to move the cursor close to where that intersection is, hit enter. I don't want to intersect with that line. I want to intersect with this line. Hit enter, enter, and it'll give me my answer. Even though the y value is off screen, I'll still get an answer. If the intersection point was off screen on the x side, then I would have to adjust my window settings. If I wanted to see this graph a little more zoomed out, I can do that. Zoom out, hit enter, and it'll zoom it out so I can see the graph a little better. Okay. Again, that other zoom feature I use, zoom box. Let's say I was zoomed out so far, but I really just want this little piece. I can use my zoom box feature to get into there. And then again, it'll give me everything a little more zoomed in. So when you guys start getting into graphs where you're graphing rates of change and we have bigger scales, then it's going to be important to use some of these zoom features. So I'll show you an example of how that relates. I want you just to go into your y equals and clear everything out of your y equals and set your screen to the zoom standard while I find a new question here. All right, so this graph here, I'm going to zoom it in a little bit here. This is a question from your guys's homework that you would have done. We can graph that on our calculator. So I'm just going to clear everything out of here. And so the equation, it says the equation is 25n. So 25n in our calculator, we're just going to type y equals 25 and then x. Now this is one where we're going to play with our window settings a little bit because we want our graph to look exactly like this graph here. And so y equals 25x is our equation, but if I graph that right now, I'm not going to see a lot. And even if I put it in Zoom standard, I'm not going to see a lot. And it doesn't make, while this is what the graph 25x looks like, it makes 0 sense in the context of the question because this doesn't look anything like this. So what we have to do is we have to adjust our window settings. So if we click on the window button, we're going to set our window settings to match what the graph is. So if you notice on the graph, we go from 0 to 60. So my minimum, my x minimum is going to be 0, and my x max is going to be 60. And the graph, if you look at the graph is going up by 5s. So I'm going to go up by 5s. You can go up by 10s as well. All that affects is how many ticks you see on your screen. So if you want to adjust the scale, it doesn't matter. I wouldn't go up by 1s because then your calculator is going to try to fit 60 little lines in that space. All right, our minimum. Our y minimum is 0, so we type 0. Our y maximum is 1200, actually 1250. So let's go up to 1300. I guess the other one went up to 65, so we could have gone higher. 0 to 1300, and notice it's going up by 100s. So that's your scale. So I'll leave that on there for a minute for you to get yours in. So x minimum is 60, x minimum is 0, x maximum is 60, x scale is 5, y min is 0, y max is 1300, y scale is 100. Now this last one on here, this x res, that's just the resolution. And I always leave it as 1. I never bother changing that one. So if you graph that, you should see something that looks very similar to what we just had on our paper. And then you can use your trace feature if you wanted to see what the value of y was when x was 30. Well, you just trace it 30. And it's 750. If you trace it 50, it's 1250. If you trace it 0, it's 0. And so anything that we do with lines can be drawn on our calculator. Any questions so far? All right, so probably in terms of graphing and what we can do with our calculators, that's probably the most I would go into for today. But I do want to show you some other cool things you guys can do with your calculators. First of all, if you're making mistakes, let's say you type something out and it's like a really crazy formula. Like in 20-1, you guys are going to see this -3 plus or minus the square root of, I don't know, 2 squared, so b squared minus 4ac. So don't bother typing this out right now. And that whole thing is in brackets. And then that's all divided by, like, I don't know, 8. I'm just making these numbers up randomly, by the way. I better make that a 12. All right. Well, let's say that I type all that out and then I realize, oh no, I was supposed to actually type -4. Well, with the newer calculators, you can just arrow up and do that. But with the older calculators, you can't. So if you push second function enter, second function entry, it brings your old stuff forward. And then you can just change it to a -4. You don't have to retype everything. And in this case, next year when you guys get into this quadratic formula, literally you have to type it in twice. You have to type it in with a plus sign right there. and then a minus sign right there. So it saves you so much work if you can just re-enter it. Some of you are going to be doing physics, and in physics, you have a ton of different constants. For example, you guys use negative 9.81 meters per second squared a ton. So negative 9.81. You don't have to, and chemistry, the same thing. Instead of typing that number over and over and over and over, you can also store that into your calculator. Of course, once we clear your calculators, they're gone. But there's a store button here. Store, alpha, and then you choose your alpha. I'm going to choose alpha A. Now, every time I type A, so alpha A, or I type second function recall, which is right above my store button, alpha A, it will bring that number up for me. So if you have constants that you're using all the time, you can train them into your memory, okay? Or train them into your calculator's memory, okay? A way that we used to pass notes in school, this is how I texted in high school, was I put my alpha lock on, and then I texted notes to my friends. This is way back before you guys had your nice quick texting. So there are some neat things you can do with the calculator.
Wait, how did you do that alpha lock thing?
Okay, so if I go second function alpha, now it's in lock mode. You notice the A is flashing, and then you can just type with the buttons. And honestly, this is how I texted in school. We passed calculators, and we told the teacher we were helping each other, but really we were passing notes. So I feel a little old now saying that. Now, there's some other cool things, and again, this stuff isn't necessarily math related, but if you like to play with your calculator, this is another thing that I did in school to kind of bide my time. And so you guys have a draw feature on your calculator, and that is right here. So second function program. Now, if I don't push second function, I just hit program. Some of you are going to have programs in your calculator. Believe it or not, you can download Mario Brothers onto your calculator. I think there's an Angry Birds that you can put on your calculator, but as soon as we clear it out, it's gone. Some of your calculators came with periodic tables and all that other stuff. So did mine, and then I cleared it once and it's all gone. You can download it all again, but the periodic table I thought was always cool to have in there. Some of you will have a TVM solver or some other finance stuff in here. You can actually create your own programs as well and type them in. I used to create my own little programs in there as well. But when you go into second function program, so second function draw, you can actually draw on your calculator. Now, there's really no point to drawing on your calculator if you got all these graphs and stuff drawn on there. So I'm going to go in and I'm going to clear out my y equals. I'm going to set my zoom to zoom standard, but you can actually turn this grid off. All right. So that is under your format. So if you push second function, zoom, there's your format. We want everything to be to the left when we're working in math. But if you're drawing or you're playing with some other stuff, you might want to turn your grid on. Okay. I'm going to leave mine off. You might want to turn your axis off. You might want to turn your coordinates off. So I'm going to put my calculator into drawing mode, and I'm going to turn all those things off. And now when I click on graph, I just see a blank screen. So again, I'll go through that. So second function, zoom. This is your format. Normally, you want everything to the left. Okay, so if ever you're missing your grid, check to see that these are to the left. But I'm going to put my coordinate off and my axis off. And then I'm going to graph. Now, right now, you don't see anything. But if I go second function draw, so second function program, there's things like I can draw a line, I can draw horizontal tangents, and so on. The tangent is kind of neat if we got into calculus, but I still don't show my students that either. But if you arrow up, it's going to take you to the pen. And this is where you get to really feel like you're doing Etch-a-Sketch. Hit enter, and then you move your pen up and down, and you can draw some pretty cool pictures. If you hit enter, it's going to turn your pen off temporarily so you can move this around. So the way that I entertained myself in math class, I built a lot of mazes in math. Very painfully slow, but I did it. And then we would pass our calculators back and forth, and the other person would do the maze. So clearly I needed some entertainment in my math class. But maybe it wasn't math, maybe it was English, I don't know. But there are some neat things you can do with that. You can also do lots of graphing with functions if you understand how certain functions work. But I'm not going to get into any of that. Like you can graph flowers and circles and all sorts of crazy stuff using functions. But if you're into drawing and you want to do that kind of stuff or play with your calculator, you need a break from Candy Crush, this might be something you could try. Now to get rid of the picture, you're going to go second, function, draw. You can save your drawings. Okay, you can store them. You can store a pic. So let's say that you want to store a picture because you want to work on it later. You can store your picture and then you can recall it. I'm not going to bother with mine right now. I'm just going to clear my drawing. So one is clear draw and it's gone. If I want to go back to doing my graphing, I'm going to have to go second function, format, and I'm going to turn those both back on. So I want everything graphed to the left. Hopefully I still got everyone with me. So when I go back to graph, I've got my graph there. So one last thing I want to show you guys, and again, this isn't anything that you have to know. I just wanted you to see what your calculator can do. If I wanted to graph an equation, so let's say I'm going to graph something really simple, 3x plus 8. So I want to graph a simple 3x plus 8. Some of you have probably noticed that off to the side, if I go past my equal sign, there is a cursor over here too. If you hit enter, it's going to change what that looks like. So you'll get a thick line, a triangle, another triangle, a key, a circle, and then it takes me to a dotted line and then back to my regular line. Okay. Each of those does something different. And some of them you're going to deal with when you get into 20-1. And so with that line there, that's just your standard line. If I click enter and I do the thicker line, it's going to give me a thick line. Okay, so sometimes if you're wanting to see your line a little thicker, I've never used that one really. This one here is for graphing an equality. So it's for graphing a greater than. So it'll actually graph a shaded portion of your graph. And you'll get into inequalities next year. Okay. We can graph less than. It's going to shade on the other side of your graph. And all the rest we don't really use. This one I just think is kind of cool to watch it graph. But I honestly don't know the purpose of it. It just kind of looks neat. You can use the circle. This one I really don't get the point of because it doesn't show anything. You just see this little bouncing ball go across the screen. And then it's done graphing. You can still trace at different points. Like I can trace at 1 and I can trace at 2, but I can't actually see the graph. So I'm not quite sure the purpose of that one. And then the dotted line, again, you can graph that. And then it takes you back to normal. So if ever you hit the enter button and you have to get back to where you started, you just have to keep hitting enter, 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 or just clear yours. So let's say that I keep going past the one I want. If I go over here and clear my equation, it clears those settings as well. So hopefully that gives you a little bit of a rundown on the calculator. Does anyone have any questions or anything else that you want to know about the calculator? Okay, I'm just going to hit end record here.